Anil Nair Classes YouTube channel. I hope I am clearly visible to you. I hope there are no streaming issues. Kindly reply in case if you are facing any issues, any audio issues, any streaming issues. Once you confirm that there are no technical issues, we will immediately start the class. We'll start the class. We were discussing prime numbers. We discussed session number 1, which is nothing but the application of definition of prime numbers. Now we will go in detail about prime number and its high level problems. Prime numbers and its high level problems. So let us start the class. As usual, 1 hour of non-stop problem solving. But before that, let us discuss some fundamental problems. Fundamentals with problem. There is a number 197000190. This number is a prime number. If this number is a prime number, what should be the value of D? Options are 1, 3, 5, 7 and 9. Very, very good question. 197000190. This number is a prime number. What should be the value of D such that that number will become a prime number? Very, very good question. Now listen carefully. 197000190. If D is 5, if the unit digit is 5, answer will be divisible by 5. Any number divisible by 5, it will become a multiple of 5. So it is a composite number. It is out. Next, if I take the divisibility rule of 3, which is nothing but sum of the digits should be divisible by 3. Sum of the digits 1 plus 9 plus 7 plus 1 plus 9 plus D. Divisible by 9, divisible by 9, 7 plus 1 plus 9, divisible by 9. That means, or it is divisible by 3. Divisibility rule of 9 is nothing but all the factors of 9 will also obey the same divisibility rule. So D can be either 3 or 9. These are not possible. And these are not possible. 5 is out because if the unit digit is 5, answer will be divisible by 5. If the unit digit is 3 or 9, that means sum of the digits will be divisible by 3. I hope the idea it is clear. Now, let us take 7. Very, very good question. 197000197. These are nothing but 197 into 10 power 6 plus 197. These are nothing but 197 into 10 power 6 plus 1. 10 power 6 plus 1, in the previous class we discussed, it is 10 square whole cube plus 1 whole cube. A power n plus b power n is always divisible by a plus b if n is an odd number. That means answer is divisible by 101. Any number divisible by 101, right? That number will become a multiple of 101. So, which it is out? 7 it is out. 3 options are out. So, remaining 3. There is no option, none of this. So, option A, it is the answer. I hope it is clear. Very good problem. Fundamental problem, but a very logical problem where the divisibility rules it is also used. 2 divisibility rules I am using. D. If D is 5, if the unit digit is 5, the number should be divisible by 5. First logic. Sum of the digits, 9, 9 out, 7 plus 1 plus 1, 9, 9 plus D. 9 plus D should be divisible by 3. So D can be 3 or 9. So 3 it is out, 9 it is out. If I keep 7, 197 into 10 power 6 plus 1, 10 square whole cube plus 1 whole cube, a power n plus b power n, it is divisible by a plus b if n is an odd number. So the answer is divisible by 101. This is one way to solve. Because 101 came into picture, I will discuss the divisibility rule for 101. Please make a note, sir. Divisibility rule, each and every concept I am discussing in class is of extreme importance, sir. Divisibility rule of 101. Now if you see here, reminder 1, 10 square divided by 101, 100 divided by 101, it is nothing but minus 1. For example, if it is 1, 2, 3, 4 divided by 101, this is nothing but reminder 12 into 10 square plus 34 divided by 101. Can I write like this? 12 into 100 is 1200 plus 34. Now 100 divided by 101 minus 1. So this is nothing but minus 12 plus 34 divided by 101. 34 minus 12. What is the answer? 22. Answer is 22. First example, foundation problem. Second example, reminder 1212 divided by 101. 1212 divided by 101. These are nothing but reminder of 12 into 10 square plus 12 divided by 101. 10 square divided by 101 minus 1. Minus 12 plus 12, it is nothing but 0. Minus 12 plus 12, it is nothing but 0. Very, very important concept. Start from right hand side. Start from right hand side. Take a group of 2 digits. Take a group of 2 digits. Alternatively add and subtract. That is the divisibility rule for alternatively add and subtract. That is the divisibility rule for 101. Start from right hand side, take a group of 2 digits, alternatively add and subtract. Why we are doing alternatively add and subtract? Because 10 square divided by 101 is minus 1. 10 power 4 divided by 101 is plus 1. Take a group of 2 digits, alternatively plus or minus 1. Suppose third example, see here, sir. 36, 36, 36, 36 divided by 101. Divided by 101. Now take a group of 2 digits, alternatively add and subtract. Take a group of 2 digits, alternatively add and subtract. Answer is nothing but 0. Answer is nothing but 0. I hope the idea it is clear. Another important learning. Please write down any 2-digit number written even number of times, any 2-digit number written even number of times is always divisible by 101. Any 2-digit number written even number of times is always divisible by 101. I hope the idea it is clear. Why? Because 36 divided by 101. Take a group of 2 digits, alternatively plus and minus. Suppose if the question is 54 written 54 times. 54 written 54 times divided by 101. Any 2-digit number written even number of times, it is always divisible by 101. I hope the idea is clear. You might get a doubt. Anil sir, what if the number of digits are odd? 2, 3, 4, 5, 6, 7 divided by 101. Divided by 101. Take a group of 2 digits. Let me take 1, 2, 3, 4, 5, 6, 7. Alternatively plus and minus. Alternatively plus and minus. 67 plus 23. These are nothing but 90. Minus 45 minus 1. Minus 46. Divided by 101. These are nothing but answer 44. 44. I hope the idea it is clear, right? 90 minus 46. The best way to do subtraction is plus 4 minus 4. These plus 6 minus 6. 84 minus 40, which is 44. Take a group of 2 digits. In the previous problem, we got 101. So I am discussing the divisibility rule of 101. Any 2-digit number, very, very important. Any 2-digit number written even number of times is always divisible by 101. Any 2-digit number written even number of times. Then we will discuss some more. Divisibility rule for 7, 11, 13 and its multiples. 77. 7 13s are 91. 11 13s are 143. 7 into 11 into 13 is 1001. Divisibility rule for 7, 11 and 13. Divisibility rule for 7, 11 and 13. Now see here. These are all derived from Fermat's theorem. 10 cube divided by 7. 7 ones are 7. Positive remainder 3. 3 cube is 27. 7 fours are 28 minus 1. Next one. Remainder 1. 10 cube divided by 11. 11 ones are 11. Negative remainder minus 1. Minus 1 cube is minus 1. Similarly, next one. 10 cube divided by 13. 13 ones are 13. Minus 3. Minus 3 cube is minus 27. Which is nothing but minus 1. According to Fermat's theorem, a power p minus 1 when divided by p, remainder will be 1. A power p minus 1 when divided by p, remainder will be 1. From that it is derived. In case if you want to know, this is a derivation from Fermat's theorem. This is a derivation from Fermat's theorem. Now, one simple example. First one, remainder 1, 1, 2, 3. 1, 2, 3 divided by 7. So, these is nothing but remainder 123 plus 10 cube plus 123 divided by 7. 10 cube by 7, it is minus 1. Minus 123 plus 123. What is the answer? 0. Suppose if I take one more example. 112, 112, 112, 112 divided by 143. 143 is 11 into 13. Divisibility rule for 11 and 13 remains same. Take a group of 3 digits. Take a group of 3 digits. Alternatively plus minus. Alternatively plus minus. This with this cancelled. This with this cancelled. Answer is 0. Answer is 0. That means there are 2 important conclusions that can be drawn from these 2 examples. Any 3-digit number written even number of times, it is always divisible by 7. First, we will write the rule. Divisibility rule for 7, 11, 13. 7 11s are, 7 13s are, 11 13s are 7 into 11 into 13. What is the divisibility rule? Start from right hand side. Start from right hand side. Take a group of 3 digits. Take a group of 3 digits. Take a group of 3 digits. Alternatively add and subtract. Alternatively add and subtract. If you do alternatively add and subtract, that will give you the divisibility rule for 7, 11, 13 and its multiples. We have to start from right hand side because unit digit starts from right hand side. I hope the idea it is clear. Now, example. 8 is written. 8 is written 6 times divided by 1001. 1001 is 7 into 11 into 13. 1001 is 7 into 11 into 13. So, take a group of 3 digits. Alternatively add and subtract. It is nothing but 0. Another beautiful conclusion. Any single non-zero digit. Any single non-zero digit written in groups of 6. Any single non-zero digit written in groups of 6. It is always divisible by 7, 11, 13. Please make a note. Any single non-zero digit written in groups of 6. When you are writing in groups of 6, you are taking in a groups of 3 2 times. Any 3-digit number written even number of times, it is always divisible by 7, 11, 13. Suppose if the question is 2 2 2 2 2 written 24 times divided by 77. 2 2 2 written 24 times divided by 77. Any single non-zero digit written in groups of 6. 24, it is a groups of 6. Answer is nothing but 2. Answer is nothing but 2. I hope the idea it is clear. These are all extremely important concepts for you to use it whenever there is a need. Divisibility rule for 7, 11, 13 and its multiples. These based on Chinese remainder theorem. Divisibility rule of 12 is divisibility rule of 3 and 4. Divisibility rule of 77 is divisibility rule for 7 and 11. 91 is 7 and 13. 143 is 11 into 13. 1001 is 7 into 11 into 13. Any single non-zero digit written in groups of 6, it is always divisible by 7, 11, 13. Few more examples. Listen carefully. 5 is written 32 times divided by 13. 5 is written 32 times divided by 13. Now see here, if 5 is written 6 times, take a group of 3 digits, alternatively add and subtract. That means 5 in groups of 6. It is always divisible by 13. Am I right? What is the multiple of 6 that goes up to 32? 6 5s are 30. Remaining it is 55. 55 divided by 13. 13 4s are 52. What is the remainder? 3. 5 is written in groups of 6, divisible by 13. 5 is written in groups of 12, divisible by 13. 6 5s are 30. Remaining is 55. 13 4s are 52. Remainder it is 3. Next it is, if you see 66666, it is written 1001 times. 6666, it is written 1001 times divided by 1001. 666 written 1001 times divided by 1001. If 6 is written 6 times, take a group of 3. Alternatively add and subtract 0. What is the multiple of 6 that goes up to 1001? 996. How many 6 are remaining? 5 6 are remaining. 5 6 are remaining divided by 1001. Take a group of 3 digits, alternatively plus minus. 666 minus 66. What is the answer? 600. I hope the idea it is clear. What is the concept that we discussed in divisibility rule of 7, 11, 13? Start from right hand side, take a group of 3 digits, alternatively add and subtract. That is the concept that we discussed. Next, the question in the mock paper, as a person who was more into content creation, on the spot I can create a lot of questions. 10 power x divided by 77 equivalent to minus 1. Right? 1 less than x less than 50. X is a natural number. How many values x can take? 10 power x divided by 77, it is minus 1. Just now we discussed 10 cube divided by 7, it is minus 1. 10 cube divided by 11, it is minus 1. Next, 10 power 6 will become plus 1. So the next is 10 power 9 divided by 7, it is minus 1. Minus 1 power odd number. Minus 1 power odd number can only give you minus 1. I hope you are all there with me. That means x can take 3 ones are 3. Odd multiples of 3 it will take. Odd multiples of 3. What do you mean by odd multiples of 3? 3 ones are 3. 3 threes are 9. 3 fives are 15. 3 sevens are 21. 3 nines are 27. 3 elevens are 33. 3 13s are, 3 15s are. Every time there is an increase of 6. So 3 plus 6k, it is less than 50. 6k, it is less than 47. K is less than 7 point something. So k is from 45 and 1, 2, 3, 4, 5, 6, 7, 8. So k is 7 point something, 0 to 7. X will take 8 values. Only if you know this concept, you can solve this question very, very fast. 10 power 3 divided by 7 is minus 1. 10 power 11, 10 power 3 divided by 11 is minus 1. 7 into 11 is 77. I hope the idea it is clear. Suppose if the same question is asked as 10 power x divided by 143, it is 1. So which power of 10 when divided by 11 I will get 1? 6. So answer is even 10, 6 ones are 6, even multiple of 3 are natural number multiples of 6. 6 ones are 2, 6 eights are. Answer will be 8. Question can be asked like this, or the question can be asked like this. Divisibility rule for 7, 11, 13. Clear. Next one. Divisibility rule for 101. We did it. Next one. Divisibility rule for a composite number 99 we will do. Because 99 it is 10 square minus 1. 101 it is 10 square plus 1. 101 it is 10 square plus 1. So 99 it will be remainder of 10 square divided by 99. 100 by 99 it is 1. 10 square if it is 1, 2, 3, 4 divided by 99. What will be the answer for this question? This is nothing but remainder of 12 into 10 square plus 34 divided by 99. Are you all with me? 10 square divided by 99, 1. 34 plus 12. What is the answer? 46. Answer is 46. So what is the divisibility rule for 99? Start from right hand side. Start from right hand side. Take a group of 2 digits. Take a group of 2 digits and add them. Start from right hand side. Take a group of 2 digits and add them. This is the divisibility rule for 99. I hope the idea it is clear. Just adding. Why? Because 10 square divided by 99, it is nothing but 1. So start from right hand side. Take a group of 2 digits. Suppose if the question is 1, 2, 1, 2, 1, 2, 1, 2 divided by 99. You don't need to do the divisibility rule of 9 and 11. Take a group of 2 digits, add them. 12, 12, 12 added 4 times. It is 48. 48 divided by 99. 99 zeros are 0. Answer is 48. I hope the divisibility rule for 99 it is also clear. Generally students who does not have these good understanding on these numbers, they will do the divisibility rule of 9 and 11. You don't need to do it. Right? 9 and 11. 9 and 11. I hope the idea it is clear. Next one. Another divisibility rule. Divisibility rule for 37, 27. Divisibility rule for 37, 27. Divisibility rule for 37, 27. 37 into 27. It is nothing but 999. 37 into 27 is 999. Let us first understand what is happening with respect to power of 10, then the process will be very easy. 10 cube divided by 37, 1000 divided by 37, these are nothing but 999 plus 1 divided by 37. 999 is perfectly divisible. What is the remainder? Remainder is nothing but 1. Similarly, remainder 10 cube divided by 27. 10 cube is 1000. So these are nothing but 999 plus 1 divided by 27. 999 is perfectly divisible. Answer is nothing but 1. So if I got 10 square by 99, answer is 1. 10 cube by 37, it is 1. Start from right hand side. Start from right hand side. Take a group of 3 digits. Take a group of 3 digits. Add it. Take a group of 3 digits and add them. This is the divisibility rule for 37 and 27. Start from right hand side. Take a group of 3 digits and add them. Once you understand which power is giving you 1, then the idea is very, very easy, sir. Reminder 1, 2, 3, 4, 5, 6 divided by 37. Take a group of 3 digits. Take a group of 3 digits and add them. 456 plus 123, which is 579 divided by 37. 37 ones are 37, 209. 37 6 are 222 minus 13. Negative remainder 13, positive remainder is add with the denominator 24. Divisibility rule for 101 we have seen. Divisibility rule for 99 we have seen. Divisibility rule for 7, 11, 13 we have seen. Divisibility rule for 37, 27. Then last. Divisibility rule for, then we will discuss the divisibility rule for any prime number. Divisibility rule for 17, 19. Divisibility rule for 17, 19. Now, if you see here, let us see. According to Fermat's theorem, 10 power 16 by 17, it is 1. From where it is derived? It is derived from a power p minus 1. When divided by p, it is 1. When a and p are co-prime, and p is a prime number. That is Fermat's theorem. So I just used it to get the 10 power 16 divided by 17. Now, if I take 10 power 8 divided by 17, 10 power 8 square is 16. X square is 1. X could be plus 1 or minus 1. Let us do it one by one by using negative remainder. 17 ones are 17. Negative remainder is minus 7. 7 power 8 divided by 17. These are nothing but 7 cube whole square into 7 square divided by 17. 343. 17 20s are 340. 3 square it is 9. 49. 17 2s are 34. 15 divided by 17. 135 divided by 17, it is nothing but minus 1. 10 power 8 divided by 17, it is minus 1. Similarly, 10 power 9, if you do in the same way, divided by 19, it is minus 1. Very, very important for an advanced level problems. 10 power 8 divided by 17, it is minus 1. 10 power 9 divided by 19, it is minus 1. So from this concept, you can develop the divisibility rule for 17. Some problems looks very complicated in mock, but once you understand, they become very easy. Divisibility rule for 17. These are nothing but start from right hand side. Start from right hand side. Take a group of 8 digits. Take a group of 8 digits. Alternatively add and subtract. Alternatively add and subtract. Alternatively add and subtract. This is the question which came in the mock paper. Most of the students thought that it is a difficult question. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Divided by 17. Divided by 17. Take a group of 8 digits. Alternatively add and subtract. So what will be the answer? Single step if you know the concept. Answer is nothing but 0. Divisibility rule for 17 is, start from right hand side, take a group of 8 digits, alternatively add and subtract. Next one, divisibility rule for 19, same thing. Divisibility rule for 19. These is nothing but, start from right hand side. Start from right hand side. Take a group of 9 digits. Take a group of 9 digits. Alternatively add and subtract. Why? Because 10 power 9 divided by 19 is -1. Alternatively add and subtract. Alternatively add and subtract. Same question, 1, 2, 3, 4. Just I will add 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by 19. Answer is nothing but 0. Take a group of 8 digits, alternatively add and subtract. That is the divisibility rule for 17. Take a group of 9 digits, alternatively add and subtract. That is the divisibility rule for 19. Just an advanced level concept. Whenever there is a need, use this concept and reduce the number of steps. What are the concepts that we discussed? First we got a question 197000119D. From there 101 we discussed. From there 99 we discussed. How to solve if it is an any other prime number. 7, 11, 13 we discussed. 37, 27 we discussed. Divisibility rule for 99 we discussed. 79, 19. Sir, is there any generic way? Is there any generic way to find the divisibility rule of any prime number? Yes, there is a way. How to find out the divisibility rule of any prime number? Sir, in our school textbooks, 3 is there, 5 is there, 11 is there, but any other prime number it is not there. How to find the divisibility rule of any prime number? To find the divisibility rule of any prime number, there is a concept that needs to be used, and that concept is theory of osculation. Theory of osculation. Fermat is one mathematician who has done a great research in the world of prime numbers. So you can type Wikipedia osculation theory, you can read it if you are curious about this theory of osculation. What does that theory of osculation states? AB. AB could be, A could take 2 digits, AB could take, say AB is a representation of a number. If you can find out the values of K1 or K2 such that the resultant is 0 or given number, then you can find the divisibility rule. That means here K1 and K2 we don't know. Theory of osculation helps us in finding the values of K1 and K2. I will take few examples, then it will be clear to you. AB is a representation. It could be a 2-digit number or a 3-digit number. If it is 101, A will take 10, B will take 1. AB, A into plus or minus K, A into K1 plus or minus B into K2. It is either 0 or AB. For example, 23. These 23 can be written as 2 into K1 plus 3 into K2. It is either 0 or AB. Just by looking at a question, K1 can be 3, K2 can be minus 2. 6 minus 6 is 0. One way, or it can be K1 can be 1. K2 can be 7. Am I right? 7 3s are 21. 21 plus 2 is 23. Either I should get 0 or AB. There could be multiple values of K1 and K2 which will satisfy these equation. Because there are multiple values for K1 and K2, prime number divisibility rule is not unique. You can derive your own divisibility rule of a prime number. Now, these 3 is multiplied by K2. K2 it is nothing but 7. So the divisibility rule of 23 is take the unit digit. Yes, I took 3. Multiply it by 7. Multiply by 7 and add it to the remaining part. Add it to remaining part. If I take the unit digit, multiply by 7 and add it to remaining digits, that will become the divisibility rule for 23. Let me do with an example, it will be clear. Number 23, it is 2 into 1 plus 3 into 7. Am I right? Suppose for example, let me take a number 8464. Check whether it is divisible by 23 or not. Check whether this number is divisible by 23 or not. What is the divisibility rule of 23? Take the unit digit. I took the unit digit, multiplied by 7. Multiply by 7. 4 7s are 28. Add it to the remaining part. This is nothing but 874. Again take the unit digit. Multiply it by 7. 4 7s are 28. 87 plus 28. 115. Take the unit digit. Multiply it by 7. 5 7s are 35. 35 plus 11. 46. Take the unit. Anyway, 46 is 2 into 23. So answer is divisible by 23. Only based upon this concept, I am taking the unit digit, multiplying by 7. Add it to the remaining part. Take the unit digit, multiply by 7. Add it to the remaining part. I hope the idea it is clear. Suppose for example, Suppose for example, 19 is there. 19. What is the concept of theory of oscillation? AB could be any number A into K1 plus or minus B into K2. It can be either resultant in 0 or that number. So these are nothing but 1 into 1 plus 9 into 2. 1 into 1 plus 9 into 2. 9 2s are 18, 18 plus 1, 9. I took the unit digit, multiplying it with which number? Which is nothing but 9 2s are 18. 18 it is 18 plus 1, 19. Now 23. If 23 it is a 2-digit number AB. What is the divisibility rule? 7B plus A. Are you all with me? 7 3s are 21. 21 plus 2, 23. Here, if 19 is a 2-digit number, unit digit is multiplied by 2. So what is the divisibility rule of 19? 2B plus A. Suppose for example, 32 49 it is there. Check whether it is divisible by 19. Take the unit digit, double it. 9 2s are 18. Add it. 342. Take the unit digit, double it. Add it. 38. 38 is divisible by 19. I hope the idea it is clear. That means you can develop your own prime number rules once you understand the concept. Prime numbers 11, 13, 17, 19, 23, 29, 31, 41, 43, right? 51, 59. Let us develop our own form of the divisibility rule of the prime number. These AB, A minus B. I hope it is clear. Sum of odd places minus sum of even places. 4 3s are 12. 12 plus 1. This is the form of a number. These AB, sir. 4 3s are 12. 12 plus 1, 13. It is 4B plus A. I hope it is clear. 17. 17 it is nothing but you can derive it in Anyway, 7. Is there any multiple? 7 5s are 35. 35 minus 1. 5b minus a. I am not touching anything other than the unit digit. 5 7s are 35. 35 minus 1. It is 34. 34 is divisible by 17. If it is b, these are nothing but 2b plus a. I hope you are all there with me. 23. 3 7s are 21 plus 2. 23. Divisibility rule is 7b plus a. 29. 3 9s are 27 plus 2. 29. It is 3b plus a. 31. 3 minus 3, it is 0. Divisibility rule is a minus 3b. 4 minus 4, it is 0. You can develop your own rule. A minus 4b. A minus 4b. I hope the idea it is clear, right? Now, 3 13s are 39 plus 4. These are nothing but 13b plus a. 13 into 3, 39 plus 4. These are nothing but a minus 5b. These are nothing but 5, 9 6 are 54 plus 5. This is 6b plus a. 6b plus a. This is how you find out the divisibility rule of any prime number. Divisibility rule of any prime number can be formed. For any prime number can be formed by using this concept. I hope the idea it is clear. I hope the idea it is clear. 4 3s are 12 plus 1 13. 5 7s are 35 minus 1 34. I hope the idea it is clear. 2 9s are 18 plus 1. 7 3s are 21 plus 2. 1 3s are 3. 3 minus 3 is 0. 4 minus 4 0. 13 3s are 39. Now there is a question which is more or less a CAT level question. AB is divisible by 19. Which of the following it is true? It is 2a plus b. It is 2a minus b. It is a plus 2b. And it is a minus 2b. A minus 2b. AB is divisible by 19. Which of the following answer option satisfies the equation? Which of the following answer option satisfies the equation? You can easily substitute and check, right? AB is divisible by 19. If I take AB as 38, 2 3s are 6, 6 plus 8 14. It is not, right? Is divisible by 19. It is not 6. It is not 16 plus 3. If AB is divisible by 19, which of the following expressions is divisible by 19? A plus 2b, it is the divisibility rule. Divisibility rule of any prime number. Divisibility rule of any prime number can be done in multiple ways. One is you can find out the divisibility rule of any prime number using theory of osculation. As the number of digits increases, osculation concept will take more time. That is the reason you can use Fermat's theorem. Fermat's little theorem. Fermat's little theorem. If the numerator it is a factorial, if the numerator if it is a factorial, you can use Wilson's theorem. That also, if time permits, we will discuss. Divisibility rule of selected prime numbers we discussed. Divisibility rule of any prime numbers we discussed. First question clear, right? Now how to use these concepts? Only concepts we will discuss it in the class, right? Next one. The largest prime factor for. Please take the question. The largest prime factor for. Question is 999, 5, 0004. It is largest prime factor. Options are typical CAT level questions, sir. 93, 97, 99 and 101. 93, 97, 99 and 101. By knowing the divisibility rule for 101, the process becomes easier. The factor should be a prime number. This is a multiple of 3. 99, it is a multiple of 3. 101. These are nothing but remainder 10 square When divided by 101, it is nothing but minus 1. Take a group of 2 digits, alternatively plus minus, alternatively plus minus. 95 plus 4, 99, minus 99, 0. Answer is divisible by 101. By knowing this concept that start from right hand side, take a group of 2 digits, alternatively add and subtract, you are able to solve the question very fast. You are able to solve the question very fast. I hope the idea it is clear. Now see here. Which of the following, a typical last few years of CAT prime number questions are like this. Which of the following is a prime number? Which of the following it is a prime number? Which of the following it is a prime number? Now, first option, 5 nines ending with 1. 5 nines ending with 1. Second option, 4 nines ending with 83. Next one, 4 nines ending with 27. 1 followed by 5 zeros ending with 1. Which of the following is a prime number? You are all these concepts of root of that number, take all the prime factors, everything will go for a toss. In session number 1, we discussed one concept, a power n minus b power n. It is always divisible by a minus b if n is a natural number. It is also divisible by, for any n value, it is also divisible by a plus b if n is an even number. N is an even number. We will use that concept, and one more concept also we can use. A power n plus b power n is always divisible by a plus b if n is an odd number. If n is an odd number. We will see this one. These are nothing but 10 power 6 minus 9. These 10 cube whole square minus 3 square. A square minus b square. It is divisible by a minus b. 1000 minus 3, which is nothing but 997. Any number divisible by 997, it will become a multiple of 997. Next one. These are nothing but 4 nines, it is 73, sir. It is 73. These are nothing but, now see here. These are nothing but 10 power 6 minus 27. These 10 square whole cube minus 3 cube. A cube minus b cube. It is divisible by a minus b. 10 square minus 3. 100 minus 3. 97. These composite, these composite. Last one, same question we did it in session number 1. 10 power 6 plus 1. These 10 square whole cube plus 1 whole cube. A cube plus b cube. It is divisible by a plus b. These three are composite numbers. So the only case which will make it prime number, it is nothing but 4 nines followed by 83. 4 nines followed by 83. I hope the idea it is clear. Idea it is clear right now. Another important concept. A square minus b square. It is a minus b into a plus b. If a minus b is 1 and a plus b is p, p is a prime number. P is a prime number. Or a plus b if it is p, a minus b if it is 1. Every prime number has only two distinct factors. Every prime number has only two distinct factors, that is 1 and itself. Every prime number has only two distinct factors, that is 1 and itself. So in case if you are writing any number as a square minus b square, either a minus b should be 1. Either a minus b should be 1 or a plus b should be 1 or a plus b should be 1, right? For these left hand side k to be a prime number. For these left hand side to be a prime number. Idea it is clear? Why? Because every prime number has got only two distinct factors, 1 and itself. 1 and itself. Either a minus b can be 1 or a plus b can be 1. Let us see this question. In the first session we discussed. Let me see. This question we will solve it, or otherwise let me see that question which is based upon this one. Very, very good questions are there. Now, this is the question which I asked you. A741. AN, it is nothing but 111111. It is occurring n number of times. A741. These is nothing but 11111 written 741 times. 741 times. I hope it is clear. Suppose A, 2 it is there. These is nothing but 1 written 2 times. 1 written 2 times is 99 by 9. 99 by 9 is 1 written 2 times. If it is 741, 10 power 741 minus 1 divided by 9. Are you all with me? 10 power 741 minus 1. What is that we discussed? A power n minus b power n. It is always divisible by a minus b. So these divisible by. These divisible by, or otherwise you take it as, just to explain a concept, 10 cube power 3 2s are 6, 14, 3 4s are 247 minus 1 power 247. I'll tell you why am I writing like this. A power n minus b power n divided by 9. These always divisible by 10 cube minus 1 into some number. Let me call it as b. Divided by 9. 10 cube minus 1, 999. Divided by 9, 111. If it is a prime number, one factor should be 1. Are you all with me? One factor should be 1. 1000 minus 1, 999 divided by 9, which is 111. And it is some number b, right? 111 into b. 111 is nothing but 3 into 37. Just by looking at a question itself, I can say that 10, these divisible by a power n minus b power n, it is divisible by a minus b. So answer is divisible by 3. Any number divisible by 3, it becomes a multiple of 3. I hope the idea it is clear. A741, it is not prime. Suppose if I take A534, 534, it is nothing but 10 power 534 minus 1 divided by 9 minus 1. These is nothing but 10 square power 267 minus 1 power 267 divided by 9. Are you all with me? So again it is nothing but 10 square minus 1 a power n minus b power n into some number divided by 9. 100 minus 1, 99. 99 means 9 goes, 11 remaining. Answer is divisible by 11. If it is divisible by 11, other than 11, every other multiple of 11, it is a composite number. These are not possible. Purely advanced level, conceptual level questions. These are not possible. These are not possible. Next one. Third one. A123. A123 is 10 power 123 minus 1 divided by 9. These are nothing but 10 cube power 41 minus 1 power 41 divided by 9. A power n minus b power n. It is divisible by 10 cube minus 1 into b divided by 9. 1000 minus 1, 999. 999 divided by 9. 111 into something. 111 is 3 into 37. Answer is divisible by 3. It is also not a prime number. I told you in session number 1, there are 237 rules to verify. Only if all 237 fails, then the number is a prime number. So, it is easy to tell whether a number is composite. Otherwise, it is difficult. A77. 77 is 10 power 77 minus 1 divided by 9. This is 10 power 7 power 11 minus 1 power 11 divided by 9. So these is divisible by 10 power 7 minus 1 into some number divided by 9. I will get 6 ones. 6 ones is divisible by 3. So these also not a prime number. All of them are right. All of them are right. All of them are correct. Beautiful question. I hope you understood the concept of how to use a power n plus or minus b power n in detail. How to use this question, we have done it. Now, these also we can use. X equivalent to, see, these are all very good level questions, sir. X equivalent to n power 4 plus 4 power n. Which of the following statements are true? X and y both are prime numbers, we will keep first option. X and y both are prime numbers. These are nothing but n square whole square. I hope it is clear. These are nothing but 2 power n whole square. A square plus b square. A square plus b square, we can take it as a plus b whole square minus 2ab. Are you all with me? So these are nothing but n square plus 2 power n whole square minus 2ab. 2 into n square into 2 power n. Are you all with me? These are nothing but n square plus 2 power n whole square minus n square into 2 power n plus 1. 2 power n plus 1. If n is an even number, even power any number, even power any number, even plus even is even. Right hand side it is an even number. Other than 2, all the prime numbers are odd. N is even, it is not possible. If n is odd number is of the form 2k plus 1. K can be 0. So these are nothing but n square plus 2 power n 2 power 2k plus 1 whole square minus n square 2k plus 1 into 2 power 2k plus 2. 2k plus 2, it is nothing but k plus 1 whole square. Are you all with me? I hope this idea it is clear. N square plus 2 power n whole square, just n is replaced by 2k plus 1. N square into 2 power 2k plus 1 plus 1. It is 2 into 2k plus 1. These n into 2 power k plus 1 whole square. N square plus 2 power n whole square. A square minus b square is a plus b into a minus b. One is n square plus 2 power n plus n into 2 power k plus 1. Another is n square plus 2 power n minus n into 2 power k plus 1. One number should result in 1. You are not getting 1. So this is a composite number. Beautiful question, sir. You will not find this kind of questions in any of your regular CAT classes. Conceptual questions, as an author of 9 mathematical books, most of the questions, right, I have seen the previous year CAT questions and I tweaked the questions. N square whole square plus 2 power n whole square. A square plus b square is a plus b whole square minus 2ab. N even, anyway it is not possible. Even plus even. Odd, anyway it is result in a plus b into a minus b. None of them is giving me 1. So it is out. Second one, see here. Y equivalent to. Don't get tensed if you see this kind of questions. Minus 4n square plus 4 minus 16n square. These are nothing but n square minus 2 whole square. These are nothing but 4n whole square. A square minus b square. A plus b into a minus b. A minus b. I hope it is clear. One of them should be 1, for the number should be a prime number. Plus 4n equivalent to 1. N square plus 4n minus 3 equivalent to 0. N square plus 4n minus 3 equivalent to 0. These are nothing but d is b square minus 4ac minus 4 into 1 into minus 3. 16 plus 12, 28. 28. D is nothing, not but a irrational number. These are not possible. N square minus 4n minus 2 equivalent to 1. N square minus 4n minus 3 equivalent to 0. Minus 3 equivalent to 0. Again D value it is B square minus 4AC. Again D is greater than 0. Discriminant is greater than 0. If n is any integer it is forming, then that value will be the answer. Let us see. If n is minus 1, is it satisfying? 1 minus 4 minus 3 minus 3 minus 3, it is not satisfying. N is minus 1, 1 plus 4, 5. Any value satisfies, then this will be a prime number, otherwise composite number. Idea is to tell you how you should write the number as a square minus b square. These is a very, very good quality question. All these questions, these morning session number 1. In case if you are seeing session number 2, please watch session number 1. These also a good question. These we will discuss in session number 3. Session number 3. These are all very, very good questions we are going to discuss in session number 3. Now let us solve this question. X comma y. X comma y. First read the question, sir. X comma y. X minus y. X plus y. All are prime numbers. All are prime numbers. Now see, if x is even, y is even, even minus even plus even. In prime number set, only one number should be an even number. But it is telling that x and y both are even. Both even cannot be possible. If I take both as odd, x is odd, y is odd, answer is odd comma, odd minus odd, even. Odd plus odd, even. There cannot be two different prime numbers which are even. Second case, not possible. X minus y, all are possible prime integers. So x minus y is greater than 0. X is greater than y. X cannot be an even number. 2 is the lowest even number. That means the only case is y is an even number. X is an odd number. X is an odd number. X comma, these 2. These are nothing but x minus 2. And it is nothing but x plus 2. If I take greater than, x equivalent to 3, 3 minus 2, 1. 1 is neither prime nor composite. X is 5. X is 5. 5 comma 2. 5 minus 2, 3. 5 plus 2, 3. X is 5. It is satisfying. Suppose if I take x value 7. X value 7. Now if you see here, any prime number greater than 3, any prime number greater than 3, we have taken it as 6k plus 1 or 6k minus 1. 6k minus 1. Am I right? Now after 5, if I take 6k plus 1, if I take 6k plus 1, this will become 6k plus 3. 6k plus 3 means it is divisible by 3. If I take 6k minus 1, 6k minus 1 minus 2, 6k minus 3, it is divisible by 3. So after 5, any number, this will be divisible by 3 or this will be divisible by 3. So the only value which will satisfy is x value 5, y value 2. 5 comma 2. 5 minus 2, 5 plus 2. Beautiful questions, we solved it. I'll just do a recap of all the problems we solved it. Don't miss out on any single problem, sir. First we discussed how to find out the unit digit of a number such that this number is prime or composite. Divisibility rule for 101, 99. Divisibility rule for 7, 11, 13. Divisibility rule for 37, 27. Divisibility rule for 17 and 19. Divisibility rule for any prime number. And some concept based application on prime numbers. I hope you enjoyed session number 2.